talking about dry ice. In front of me I have a plastic bottle. It could just be a water bottle. I'm using like a spray bottle without the top. I have 2 balloons, a clear plastic bowl with warm water, some dry ice, I have gloves, safety goggles, hammer. Okay, so first thing, let's see what happens when we put some dry ice into a bottle. Now, you should either use tongs or gloves. That's too big. So we need to break it up into little pieces, and it's gonna kind of go everywhere. Let's try it on here. Okay, so we're gonna get little pieces into the bottle, and it will make funny sounds on the plate, and it'll make funny sounds if you put it on metal. Let's try to break this up one more time. Okay. I don't know if a ceramic plate's the best idea, because you might end up breaking it. Let's see. Oh, that is cold. Now if it goes on the floor, it'll just sublimate quickly, so you don't have to worry about puddles or anything, because it is dry ice. Okay, so dry ice in, and we are going to stretch a balloon over it, which you won't be able to do with your gloves on. So let's see what happens, and we'll talk about what it is. Okay. Okay, so dry ice is made out of carbon dioxide, and if you notice the bottom of the bottle, the balloon's blowing up, but there's no liquid, and that's why we call it dry ice. So it's sublimating. That means when it skips the liquid step and it goes straight from a solid to a gas. It does this on Earth at our standard pressure. However, if we were on a different planet or under a different pressure, then it could liquefy. Let's see. So we're gonna let that balloon inflate. And so dry ice, we said, was made out of carbon dioxide. So you could ask your students, what's in the balloon? And they might say it's filling up with air, but really we know that it's letting off the carbon dioxide gas, because that's what it's made out of. So this balloon is being filled with carbon dioxide, and we will prove that a little later once we allow it to blow up some more. So then we have a bowl of warm water. We use plastic because glass might not be good with the extreme temperatures, and I know the dry ice is around minus 79 degrees Celsius, so, and regular ice is around 0 degrees Celsius, so this is much colder. Okay, so now let's see what happens when we put dry ice into the hot, warm water. Okay, so it immediately starts to bubble. You want to use a clear bowl because you want to point out to students down here what color the bubbles are. So the first thing we notice is this stuff up top, but let's talk about the bottom first. So these bubbles, as you can see through the bowl, are clear. So you can ask a question, what color is carbon dioxide? Because we just talked about how this is carbon dioxide filling up this balloon. So the bubbles coming off of the block of ice must be carbon dioxide. So what color is carbon dioxide? And most students are going to say white because they see all this stuff up top. But if you look into the bowl, you can see that the bubbles are not white, they're clear. So that tells us carbon dioxide is clear, which also tells us that this stuff up top isn't just carbon dioxide, right? Then what is it? What does it look like? When you ask this question, most kids will say smoke as their first answer, but we try to avoid that because it's really not smoke, and it's something that occurs in nature, so we try to lead them towards that. If you live in a foggy place, this will be easier, but if not, then you'll have to help them get to the answer of fog, because that's really what we're creating. And you can tie this into a weather lesson if you want. So basically, the cold carbon dioxide bubbles are coming up and they're condensing the liquid, or the water vapor that's in the air, into fog. So this is essentially a cloud we have right here, or fog. So it might stop after a while if the water around the block freezes, so you might have to like break it up so that it'll continue this process, or you can always just add more dry ice. And every time you add a new piece, it'll go more rapidly. So basically you want them to get to the point that this is fog, this is a cloud, and that fog forms when the air temperature is cool enough to condense the water vapor that's in the air. And so that's why we get clouds to form, or fog to form, especially in coastal areas, because the air over the water is going to be colder, and the winds and stuff like that are going to bring in the cold air, and that cold air is going to condense our water vapor and make fog. Okay, so now heat it up a little bit, let it sublimate a little more, and I'm going to blow this balloon up and try to get it about the same size with my breath. So the air around us is 78% nitrogen, 21% oxygen, and 1% everything else, including this carbon dioxide. When we breathe out, it's 78% nitrogen. We use about 4% of the oxygen, and we let the other 4% out. So it'll be 4%, or we let 4% carbon dioxide out. So it'll be 4% carbon dioxide, about 17% oxygen, and 78% nitrogen. But you can look this stuff up, and let's see how we can compare these two balloons. Okay, that's enough. So I'm going to tie this one off, and then I'm going to tie our blue one off. And let's remember that the blue should be the one from the dry ice, so that one's carbon dioxide. I'm just going to set this down for now, grab it in a second. Now you have to carefully take this off the bottles just because you don't want it to rip. It's going to be more difficult to tie. I think I got it. Okay. Okay. So what you can now do is you can have students feel the difference between these two balloons, and the one with the carbon dioxide is noticeably heavier. You would think that most of the weight of the balloon would come from the balloon itself, the rubber, but you can actually tell the difference in the weight of the balloons. And if you're in a chemistry class or even an 8th grade science class, you can calculate the difference between the mass, like grams per mole, of carbon dioxide and of the air. So I did some quick calculations. This one is about 44 grams per mole, and this one, which is mostly nitrogen, nitrogen's about 28 grams per mole. So this one is significantly heavier than this one. So that's something you could pass this around, have your students try it. If you had students doing this experiment themselves, then they could each have like a plastic water bottle or a plastic like flask with a small top, and after they blew up their balloon, they could add water to it, and the fog would be created just in this bottle. So that could be how you could individualize this. And this meets 5th grade standards about phase changes, and 8th grade standards, and chemistry standards in California.